All right. So, question number one.
Mm. Sir, I didn't exactly study this chapter, but I'll refer the book, okay?
Sure. Keep the book open in front of you, and that's fine.
Sir, the first answer is A, or it is B. B.
B
No,
is
no, no.
correct.
Brown.
Right. B is
Eh?
correct. It's a red brown liquid. At room temperature, bromine is a liquid.
Uh-huh.
And that's the only non-metallic liquid at room temperature among the periodic table. Okay. So
Yeah.
moving on. Part B.
So we have to balance the equation. We have two bromide. Um, Sir, at the last we'll put two, so it'll be two and
2
ABR.
NABR. Okay.
And then at the starting also we'll put two, and then in the middle put one. Is it?
2, 2, and 1. Perfect.
Oh.
Good. Moving on. See what we have next. Yeah, perfect question.
Okay.
This
Student carries.
is the most common thing they come up with as a question from the Halogens chapter. As you can see in front of yourself, there are many solutions which are being reacted with one another. You would see halide solutions, chloride, bromide, and iodide. Apart from that, you will see the halogens in their original uh, uh, appearances, bromine, chlorine, iodine. And as soon as you see something like this, although that's written on the very top of the question, that's the very first line of the question, these are displacement reactions, you should get the idea. Now, displacement reactions are one of the most common ones from the halogen chapter that they ask questions from. So this is one of those questions, and expect many more questions like this to come ahead.
Yeah, right. She had some hallucinations. Okay. The table, okay. Lithium chloride. Okay. So, sir, those are the solution, and she added like bromine, chlorine, chlorine, and then iodine.
Right, right.
Okay. The table shows that she did not do three experiments. Suggest why she did not do.
Now, this is a question out of common sense. It's not a very difficult one or a hard question. It's simply common sense.
Mm-hmm. Um, um, sir, I don't know. Mm.
Okay. Uh, a little bit of hint. I'm not going to tell you the answer. You're going to figure it out yourself. But as soon as you see not done written in the table, what I suggest you to is to go to the very start of the row on your left, try to find which halide it is, and exactly at the same time, go very top to the column and try to find which halogen it is. Now, supposedly, I'm going to do it for the first one. If you talk about this not done, as you go up top, this is bromine, and if you go on your left, this is bromide. You're supposed to do that with the other not done, and that will probably lead you to the right answer. Go ahead, try to do it.
Mm, then, sir, is it because like they won't react with them own self, something like that?
Right. A perfect answer. What's the point of displacing if bromine is going to react with bromide? What would you displace?
Mm-hmm.
Right? So it makes no sense to displace bromine with bromide. And of course, since there won't be any difference in reactivity, so there would be no reaction as well. So moving on, apart from what we just called as, okay, I think you can see the last question on this page. So yeah,
Yeah.
there are also no reaction, and there are three of those in the table. What does that mean?
Mm,
Apart from not done,
yeah. No
why is there
reaction.
no reaction in the table? Now, this one has a perfectly good scientific logic. This is not a common sense based question.
Sir, in the first one, with the solution lithium chloride, and then it has no reaction with bromine. Sir, both are from group 7. Iodine also. So, no reaction.
So, what do you say?
Uh, so I only heard one thing that they all are from group 7. That's why there's no reaction. Because,
Think about it. The others are also from group 7. So, why does a reaction occurs over here and here and here? They're also from group 7. They're not out of group 7, but not here, here, and here. Try to make some sense out of it. That's not the right answer.
mm, so is it because like bromine cannot like displace chloride because it is more reactive? No.
Exactly. But a little bit of error is still there. So, since there are three no reactions, so there are three possible explanations, one for each of them.
Hmm.
So, look again, look on your left and look on your top and try to find a reactivity difference pattern. This is too big of a hint.
Mm, but sir, I don't understand one thing. Over here,
Yes,
like in the first one, it's lithium chloride, and as I said before, like bromine cannot replace or displace chlorine, but
Because
because it is more reactive.
which is more reactive, chlorine or bromine?
Chlorine.
Right. Chlorine is more reactive than bromine, so bromine cannot displace it. What about the reason for the other two?
Other two. Okay. So it's iodine and bromide. Oh yeah, sir, it's the same thing that iodine is less reactive than bromide, so it won't displace it.
Right. So iodine is less reactive than bromine, so it won't displace it.
But sir, my question was, in if you see in the second row over here, how does? Oh wait, okay.
Iodine is less reactive than bromine, iodine is less reactive than chlorine. So iodine cannot displace any of them. Hence, there are two no reactions in case of iodine. There is only one no reaction in case of bromine because
Yeah,
bromine is less reactive than chlorine. Chlorine
yeah,
is not less reactive than either bromine or iodine. So in case of chlorine, there are no reactions written over there. I hope that makes sense.
yeah. I got it.
Okay, good, good. So what we do is that we try to take it like this. Chlorine goes for both the reactions because it's the most reactive one. Iodine goes for none of the reactions because it's the least reactive one. Bromine cannot displace chlorine, but bromine can definitely displace iodine because it's more reactive than iodine, but less reactive than chlorine. I hope this all makes sense now.
Yeah,
Does it?
yeah.
Good. This clarifies displacement reactions, which, if come further, would give you an easy answer. Okay. Number three.
The student writes a word equation for the experiment which a reaction occurs. Bromine plus potassium iodide. Okay, in the name of the sentence is incorrect. Okay. Um, so what should we exactly do? Like, hmm,
Think about it. You have just done previous questions. You can see the pattern and you can then try to see which one is wrong. Try to go with the spellings of each and every substance in there one by one. You'll find out the mistake eventually.
all right. Iodide. Bromine spelling is right. Potassium is right. Iodide.
Good. So far, so good.
And then potassium. Again, it's right. Yeah. Bromine is also right.
Is it
Iodine.
supposed to be bromine? When you
It should
write
be
it with
bromide.
potassium, is it INE or IDE?
Sir, it should be bromide, right?
Right, that's the problem. So the correct name of the complete substance would be,
Potassium bromide plus iodine.
it's just one name they require. So potassium bromide. All
Oh,
right.
okay.
Okay,
Yeah.
moving on. Part four.
A reaction occurs when the students add chlorine solution to the potassium iodide. Oh wait, the answer was hidden down only, right?
Right.
Okay. solution. Complete the equation for this reaction. Potassium or chlorine. Okay. So it would be. So I think chlorine will displace iodine.
So what would form?
It
Can you
would
tell me
form.
out loud the substance?
It would be potassium chloride plus
Right.
iodine.
Good. And KCl and
Iodine.
good. Now go ahead and balance the equation.
Okay, so here we have two chlorides. And sir, in the second last one, can you put two at the front?
Hmm?
Can you put two? No, no, no.
To
The
where?
second last.
This one?
Yeah, if you put two over here, and then we have to balance. Oh yeah, wait. We have two chlorine over there. Now we have two chlorine over here, but here we have two potassium as well. So, sir, there also will put two.
Okay.
And here, okay, and now we have this one. We have two iodine also, which will go over there. And we already wrote two. That's it? Or
That's it. Well done. Okay, moving on. Though part 5 exactly is not a part of this chapter, but since this might not be included in the test, might not be excluded out of the test, so let's do it.
part 5, all the displacement of redox. State the meaning of redox. Okay, sir. Redox means when oxidation and
Hmm,
reduction happens simultaneously.
perfect. Simultaneous oxidation and reduction reaction. All right. Now, moving on. Number 6.
Okay, the ionic equation for another reaction is bromide plus 2 iodine
This
equal
is
to
also oxidation reduction. Okay, let's skip it. Let's stick to halogens since that's not a part of the chapter. Okay. Question number 2.
bromine and iodine are halogens. Complete the table by giving the color and the physical state of this halogens at room temperature. Okay. For bromine, sorry, for bromine, the physical state will be liquid,
Perfect.
and iodine it will be solid.
That's
Oh wait,
written.
the
Okay.
color will be for bromine. No, iodine. Um, gray, solid.
Good. Gray solid. All right. Okay. Let's leave the dot and cross diagram behind. This is not what we are supposed to do in this portion. Also this. Okay. Number 3. This is a big question and an important one. Again, you are facing displacement reactions.
Uh-huh.
So the examiner is not putting it in the same words, but I hope as soon as you read the question, you understand this is an experimentation about displacement reaction. Go ahead.
Solution is add with aqueous solution of this substance bromine, chlorine, iodine, potassium bromide, potassium chloride, potassium iodine. I okay. Describe two experiments from using the same sum of the solutions to show the order of reactivity of bromine, chlorine. Oh, okay. Your answer should include the observation that the student would accept to make and a chemical reaction for one of a chemical equation for one of the reaction. First, look part one. Describe two experimental it is. Um, mm, experiment. Hmm. But sir, how what two experiments? Like two experiments the student could perform using the
Two
solutions.
experiments, two different reactions. The ones we were just talking about, which one is more reactive than which one, so which two solutions you can make. You have the same experiments written in the book as well. There are actually three in the book in total. You're just supposed to perform any two of them.
Like sir, for example, bromine with
Mhm.
potassium chloride, like this.
Uh, yeah, like this, but your example is not correct because there would be no displacement. Bromine is less reactive than chlorine. Choose the
Okay.
right compounds or solutions. Otherwise, the way you're telling me, that's fine. Also, you need to add a chemical equation in there.
Oh, okay. Sir, what about like chlorine and potassium iodide?
Perfect. That's one example. What would happen?
Uh, chlorine would displace iodide,
Right.
forming
And
the
uh
equation potassium chloride, which will be K. I should write the right.
KCl, we just wrote the equation in the
Uh-huh.
previous question.
ACl,
Right. What else?
and then mm, now I have to give the second, right?
Right.
Okay,
And it
second.
could also form iodine, not to forget. Okay. But
Yeah.
if you read the second last line of this question, and I'm going to quote it to you, your answer should include the observations that student would expect to make. So this time, we're also going to talk about colors. So what would be the color change in the experiment you just told me? If you make fluorine with potassium iodide, you're going to form potassium chloride and iodine. This is just the background chemistry. You won't exactly see it in front of you. The observations that you would observe in front of you are usually in the form of color changes. So let me know what would be the color changes associated with this reaction. You can also take the same thing out of the book. That's completely up to you.
Mm-hmm. So chlorine has green, okay, and then potassium iodide,
Fluorine has pale green appearance, right?
and potassium iodide. Iodine has gray solid.
But
So,
when we're going to use a solution, what would happen?
but sir, how would we know the color? Like,
The colors are mentioned in the book in such a
yeah,
specific way that you are supposed to memorize those.
yeah. I'm not. I'm saying like after they have been reacted, how would we know the color? Like what?
We will see the color in front of ourselves. That's what observation means. That there would be a color change because of the formation of iodine in the reaction, and what color change would be observed because of that formation. So that's the main question of the examiner. That some chemical reactions bring about a color change. What color change do you expect to see in this reaction in specific?
So gray and green mixed together.
Hmm, no, it's not gray. Oh, come on. Okay, let's get back to the book since we are having a hard time understanding it. And I believe we need to go a few pages back, many pages back, not just a few.
Sir, I understood the question, but I don't know how, like, how we'll mix it. Like, that's the thing.
Let me clarify. Just a minute.
All right.
Okay. As soon as we get to these reactions, right? You see many reactions in front of you. You just performed this one right here. When chlorine reacts with potassium iodide, it forms potassium chloride and iodine. Now, your book clearly tells you that you get a brown or an orange color for the dilute solution of iodine because iodine will be present in the form of a solution, not in the form of a solid. And the diagram is also given over here to give you a better idea. So that's why you were supposed to remember it. Also,
Oh,
if you're going to do the same reaction with bromine instead of chlorine, you're also going to get a brown solution of iodine again. So in most of the cases, you get orange or brown solution. And this is the third and last reaction which is possible. In this case, you don't form iodine, you form bromine. And again, you're going to get an orange or brown solution. And that's the reason explained over here for orange or yellowish appearances. I hope that makes sense, right?
yeah, yeah. Okay,
Good,
got it.
good. So you were supposed to remember these colors and you're supposed to mention them over here. So there are 5 marks in total. The first 2 marks are for the first uh, case. For example, you picked chlorine with potassium iodide. It is going to form potassium chloride and iodine. And as soon as you tell them this, you get 1 mark. When you tell them the observations you're supposed to make, the pale green gas, when bubbled through a colorless solution, turns to orange or brown, this would get you the second mark. For the second case, you can take the example of chlorine, but this time you can use potassium bromide and this would form instead you can use bromine and you can take the same solution potassium iodide and again you're going to form iodine. Again the colorless solution will turn to orange or brown because iodine formed, and again you get the next 2 marks. Finally, if you write one of the equations correctly and balance that correctly, you will get the fifth mark. That's how all the marks, all the 5 marks are justified. Make sense?
Yeah. Okay.
Okay, make sure you quote all of this properly. And I'm also going to show you the answer in just in case so that you have a better idea what I'm talking about. So
So,
we
sir,
can go
exactly.
on since this is question number 3. Take a look. If we if you mention that you're adding chlorine to potassium bromide and the solution turns orange, you get 2 marks. If you're telling them bromine was added to potassium iodide, the solution turns brown or orange, it means the same thing. They can accept red, brown, or orange. So you get the first 4 marks. If you write either one of the equations, you can get the fifth mark. If you're not mentioning these 2 equations, since you're not mentioning this, you never mentioned this is an example. This is also acceptable because this is the third case, and you mentioned this one. So if you mention all of them in appropriate terms with colors, everything is required, you'll get all 5 marks.
Mm-hmm.
Make sense?
Yeah.
Now, just writing red or just writing yellow will not cut it. You either need to mention brown or you need to mention orange. Remember, these 2 colors writing alone, they will not get you the marks. So make sure you either mention orange or you mention brown.
Mm-hmm.
So
All
I'm going
right.
to take you back to our original paper. And let's move to the next question, question number 4.
Okay. Group 7. Darkest. Sir, iodine and Um, Bromine,
Iodine and bromine. Perfect. And can you tell me what the reason for your choices are? Is
because they asked the darkest color. So if you see the table over here, iodine has like gray, and bromide has brown, like red brown. So obviously they are darker than yellow and green. So yeah.
okay, that's good. But remember, the trend is the elements on the top of the periodic table are lighter or paler in color as compared to the bottom. As you go from top to bottom in the group, the color gets darker. So the two bottommost elements mentioned, bromine and iodine, would have the darkest colors. If there was astatine mentioned, astatine and iodine would have the darkest colors. Then we won't choose bromine. Keep that in mind. The
Mhm.
from top to bottom, the more towards the bottom you go, the darker the color of the halogen is. That's the trend. Okay, moving on. Part B.
The equation, okay, of hydrogen and chlorine. What different names are used for the product depending on its state symbol? What
Tricky
are the
question. Not exactly from this chapter, but very much related, so we are not going to skip it.
uh-huh. What are the name used for hydrogen? Oh, okay.
One of them is
Uh,
gas, one of them is aqueous, and this totally changes the name.
sir, I'm not sure, but for the gas, will it be hydrogen chloride, and for the aqueous, it would be chlorine, like hydrogen chlorine? No.
For the gas, it would be hydrogen chloride. You're perfectly right. Now, what would that be if we add HCl to water? A little bit of a hint. When we add HCl to water, it becomes an acid. So the name must contain the word acid.
Hydronic acid?
Hydrochloric acid.
Oh yeah,
Hydronic. There is
hydrochloric.
no acid by the name of hydronic. So hydrochloric acid. So the one on top is hydrogen chloride. It's a gas. When we dissolve that gas in water, it becomes an acid, and that acid is commonly known as hydrochloric acid.
Sir,
All
can you
right.
repeat the aqueous part again? Like how it will turn to like gas? I mean,
When we
acid.
dissolve the HCl gas, hydrogen chloride gas, in water, it becomes hydrochloric acid.
All right.
And as we have studied in the chapter of acids and bases, though this is not from this chapter, when we add HCl gas to water, what happens is that it literally reacts with waters and produces ions. It produces hydrogen positive ion and it produces fluoride negative ion in the aqueous system. And since it gives this hydrogen positive ion, we call it hydrochloric acid, hence the
Mm-hmm.
name hydrochloric acid. This is hydrogen chloride on top, this is hydrochloric acid. I hope that clarifies it.
Yeah.
Part 2 really isn't a part of this chapter, so is part C, so let's not do it. So is part C, not from this chapter, not from this chapter, not from this chapter either. Let's keep on moving. No, not from this chapter. Again, the same. Okay, this one is related to halogen. Go ahead, part F.
Potassium bromide can be made by reacting potassium with, okay. Explain what it is will to be sure whether the reaction between potassium and bromine gas would be more vigorous than the reaction between sodium and chlorine gas.
Okay, no, this is not from this chapter. Let's leave it. Because you would be able to distinguish between bromine and chlorine. By the way, which one is more reactive, bromine or chlorine?
Chlorine.
Chlorine. Perfectly good. That's what I wanted to know from this specific question. We're done with this sheet, so let's close it down. Move on to the next one. Two. Okay, the next one is this.
Hmm.
I guess I
Right. Uh,
closed the wrong worksheet, but yeah, let's go with this one. And let me
uh,
zoom out a little bit so it's easier for you to read most part of the question. There you go. Question number 1A.
color of chlorine will be green, and boiling point of iodine will be um liquid. Wait, no. Mm, I should predict the value of boiling point of
Predict,
iodine.
just a prediction.
So first one is okay. So I think it's um,
You can even predict a range, that's fine. You can predict a single boiling point, that's all right. Come on, this should be easy. It's just a prediction. You
I
don't have
don't
to be exact.
like 47.
That's not right. You're not following the trend. Try to follow the trend. Going from the boiling points from top to bottom, there is a proper trend. So you need to follow the trend. What's the trend? Is it increasing? Is it decreasing? What's happening?
It's increasing.
It's increasing. So definitely it would be greater than 59. So what do you predict?
65.
65. Let me tell you, anything higher than 60 or around 80 or 100, those would be correct. So let's consider it correct and let's move ahead. That's how simple it is, right?
Yeah.
Okay, so moving on. Next, this is great. Okay, let's need a little bit of the table. There you go. You're supposed to tell the color as well as the physical state.
Mm. Oh, where it is predicting. So in halogen, it's not there like predicting the properties of acetate.
Yeah, predicting the properties of acetylene is the last part of this chapter, and we predicted almost everything about acetylene, be it the melting or boiling points, be it the physical state, the color, how it would behave in terms of reactivity, would the displacement reactions be possible or not, everything. So out of
Acetate.
those two have been asked as a question over here, the color. And since I've already explained that color and the darkness of that as a trend in the group 7, and there's physical state on top of it. This should be easy,
Oh, okay. So, as you said, sir, that iodine and this acetylene, right?
right?
Are like the dark. They have the darkest color. So, as iodine has gray, so this is black, right? Hmm?
You said it in such a slow voice that it's almost inaudible for me. Be a little loud.
Sir, I'm saying that as you said
No,
previously
just the
that.
color. I heard the rest.
Oh, okay. Black
Black. Perfect. Great answer. Moving on to physical state.
physical state. Like we have to say solid, liquid, gas, like this.
Right. Predict one of these.
Sir, what's iodine? Is it solid, liquid, or gas?
Remember, fluorine and chlorine are gases at room temperature. Bromine is a liquid. Iodine is a solid.
So this will also be a solid.
Perfect. Now
Okay.
you're getting a hang of it. Good. Good. Moving on. D.
Outer shell. I mean outer electrons. Um,
Outer electrons. Perfect. Part C. That is C. Outer electrons. Okay. E.
again that same thing. That okay.
No, these are correct and incorrect statements, and you are going to not only identify which statements are incorrect, you're also supposed to correct them with the correct word.
So here spellings are wrong, right? Not
No,
the
no, no,
question.
anything. It can be anything. But there is only one incorrect word in every statement. That can be spelling, that can be something else, that can be state, that can be the explanatory word. It can be anything really, not just spellings. And plus, I was mentioning spellings over there because spellings changed the whole name. So actually, what was incorrect over there was the name, not just the spelling.
Uh-huh. The
Spelling was
reactivity.
just a good trick or a good way to identify the issue, the problem at hand.
So in the first one, the reactivity of the elements decreases down the group. That's correct. The reactivity of
Good.
the elements decreases down the
Moving
group.
on. Second
Okay.
statement.
The elements form ions with a single positive charge.
Now, this whole part E as a question has been taken from the summary of this chapter. And the summarizing points are almost given at the very end of the chapter,
Uh-huh.
right before the extension part. So it would be really easy for you to read the statements from here, compare those parts from there, and then find out the incorrect words, identify them, and correct them too. Go ahead. Since you're correct with the first one, so we can start reading from the second statement. What's wrong in the second statement if it is wrong? If it's correct, let me know.
Oh, sir, I got it.
Good. And what is it?
They said positive. It should be negative.
Perfect. So the first incorrect word is positive, and we need to convert it to negative. Third line or the third statement.
The formula of an acetylene spelling. Yeah, it's right. Acetylene. Yeah. A molecule is
82.
molecule Sir, it should be molecules.
No, it's fine. There's no problem with this word.
Sir, there is no galat in this.
There
Is
is
there?
no error in the statement. There is nothing wrong with the statement. Moving on to number four. And obviously, since there were a total of five, you've already identified the two correct statements. That means both fourth and fifth are wrong.
Mm-hmm.
This is what simple calculation tells us. Now we need to identify which word in statement number four and which word in number five is wrong. Go ahead.
Okay. The equation for the reaction between chlorine and potassium bromide solution is okay. Chlorine.
And then this is a great way of trying to fool the students around. You need to find out how they are trying to fool you in this specific statement. It's a good one. It's actually a funny one.
Okay, let me see. The equation for the reaction between chlorine and potassium bromide solution is so chlorine. Sir, it should be K, not Na, because that's sodium.
Right, right. They're writing potassium, but the formula or the symbol is for sodium. They're trying to fool you out of it. But you
Okay.
clearly find out the problem and got us the correct word. Moving on to the last statement.
In the reaction between bromine and potassium iodide, okay, bromine acts as a reducing agent. Oil rig. Reducing means gaining, right?
Reducing agent means who pushes others to gain electron and itself loses electrons. That's what reducing agent means.
Hmm.
It does not it by itself gain electrons. Actually, it itself loses electrons, and the other one, the other reagent or reactant reacting with it gains electrons.
Sir, is there a mistake here?
There's
Uh,
definitely a mistake in this sentence. There are a total of five sentences. Three were wrong, two were right. The first right sentence is statement number one. The second right is statement number three. So definitely there is a problem with this one. Now we need to identify which word in this entire statement is wrong. Which one do
sir,
you suspect to be wrong?
sir, uh, is it bromine act as a reducing agent? Oh, I think I got it. So, here they're saying that bromine act as a reducing agent, and you said that reducing agent means um
Itself loses electrons,
lose
other
electron.
ones gain electron.
So they're trying to say that over here iodine displaces bromine, right? But it's wrong because bromine is more reactive than iodine.
So bromine should act as a which agent?
Uh, what's that?
Definitely not a reducing agent. If it's not a reducing agent, what kind of agent would bromine be?
Gaining agent?
Oxidizing agent.
I
Let me
forgot.
remind you, halogens are oxidizing agents. They are not reducing agents. In the displacement reactions, the more reactive halogen is usually the oxidizing agent. So the incorrect word over here is reducing, and the correct word would be oxidizing.
Uh-huh. All right.
Make sense?
Yeah.
Why? Because you were right with your whole logic. Bromine gains electrons in this case. And if it gains electrons, it should be an oxidizing agent, not a reducing agent.
Oh
So
yeah.
if I be right, there are these three words. We are going to cut out positive, replace it with negative. We are going to cut out potassium and replace it with sodium. And we're going to cut out reducing and replace it with oxidizing. Remember, do not cut out sodium because they are talking about a correct word. And the word that is wrong is potassium. It should be sodium. The symbol is fine. Remember, you
Mm-hmm.
need to identify a word, not a symbol. Okay? So, moving on. This is diffusion. Let's not do it. Diffuse again. More. Bonding diagrams. Okay, number
So,
4, part
uh,
A. This should be easy since we are done with it, and you're trying to do it again and again. This should be easy.
okay. So for fluorine, the physical property will be gas,
Physical
and
state, and yes, that is right.
oh yeah, okay. And for bromine, the color would be red brown,
Perfect.
and for acetone, the room temperature will be uh, solid. Yeah. I remember.
Solid. You also answered it in the previous question, so that should be
Yeah.
easy. Okay, moving on.
Chlorine acts with the hydrogen to form hydrogen chloride. A piece of magnesium ribbon is added to hydrogen chloride in three separate experiments under the different conditions. The table below shows the observation made under these different conditions. Write down the formulae of two ions formed in the experiment 2. Food and water.
Don't get worried because of the whole table and the difficult way to put up the question. The answer is really easy. So think about it. If we are, as a part of condition, dissolving the hydrogen chloride in water, and as observations, there is a magnesium ribbon which gets smaller and smaller, and there are some bubbles. It should be easy to answer.
So, sir, the positive ion would be produced. So, it can either be magnesium or hydrogen, right?
Perfect. Either one is correct. So whether you're writing this as your positive ion or whether you're writing this as your positive ion, it would be correct. But remember, your charges should be right. H
Mm-hmm.
is just positive and Mg is too positive. What about the negative ion? This should be even
Neg-
easier than the positive ion.
yeah, negative can be chloride. Yeah.
Perfect. Negative can be chloride. It's just one negative ion, so it's going to be Cl negative. Okay,
Mm.
moving on. Let's
Identify the
forget it. Not a part of this chapter, not a part of this chapter, not a part of this chapter. Okay, question number 5, part A, 1.
okay. Predict the chlorine at room temperature. Gas.
Gas. Perfect. Part 2. Part A, part 2.
How room temperature compared to iodine? So iodine is gray solid, so it would be, sir, black.
Black. Good. Moving on to part B.
Okay, halides one.
This time, notice it's a similar displacement table, but instead of writing the answers about reaction done, this time they're talking about what is the color of the solution in terms of the observation. So they slightly changed the table, but let me tell you, let me assure you, the questions will almost be the same. Go on.
Okay, a sample of each halogen was added then to okay some of the solutions. Table to show the results. Okay, so just why there is no reason to add chlorine to lithium chloride solution. Sir, obviously it won't react with its own self.
And what's the reason?
Mm, is it because that chlorine?
Will not displace chloride ion. Or even
Is
if
there,
the displacement occurs, there won't be any difference. There won't be
yeah.
any observation to see.
Oh, sir,
Okay.
we can also write that they both have the same reactivity. So they are because they are the
They
same
both
element.
have the same reactivity. That's also a perfectly good answer.
Why there is no reaction when? Oh yeah, because bromide is more reactive than iodine. Iodine.
Perfect. Three.
Name the substance. Mm, name the substance with the brown color that is formed when chlorine was added to potassium. Brown color when chlorine was added to.
For this answer, I specifically went back into the book and I explained this answer by properly pointing it out on the book why the color is brown or what is the substance that causes the entire color to be brown.
Let me see. So it is chlorine and potassium iodide.
For this specific answer, I am going to tell you the answer because you might be stay stuck for a longer duration of time. The responsible substance is iodine, but writing only iodine will not get your answer right. So please note you're supposed to write iodine aqueous. If you're not writing this, what you can do is that you can write it in words and you can write
Iodine
iodine
solution?
solution. So
Oh
whether you
yeah.
write iodine aqueous or you write iodine solution, it means the same thing.
All right.
We're good? Okay, part 4. And again, a tricky question from a very small exam hint of the book. This exact question has been taken from an exam tip from the book.
All right. The reaction between bromine and potassium iodine solution is displacement reaction. Okay. What is the correct description of this reaction? Oh, okay. Sir, bromine displaces iodine.
And the letter is A, B, C, or D?
Uh-huh.
Because I'm
D.
been out good. D. D as in door. And finally, the last equation.
I'm so
I'm
excited.
happy that you didn't fall for the previous trap. This D part was more like a trap, and I'm happy that you answered it correctly. Moving on to the
Right.
last part, the last question for this entire worksheet.
Complete the chemical equation for the reaction between chlorine and potassium bromide solution. So chlorine is there, uh, potassium bromide, and chlorine will displace bromide.
Of course, and what would form?
It would form KCl
Perfect,
and bromine. Yeah.
which is PR2. Now let's go ahead and balance it up. The left side
Okay.
is already balanced because we don't have any fill in the blanks over here. So we only need to balance the right hand side.
I will add two.
Where?
Uh, wait. Let me just check
KCl or
one.
BR2?
KCl.
KCl. We'll add 2 before KCl. And now that's the perfect equation. And I hope this gives you more confidence, right?
Yeah.